Okay, so this one is the one, the dreaded one that most people don't like to do, but it's actually not that bad. It's example 4 for chapter 8, section 3, and it says construct a flow chart to prove that if a quadrilateral has congruent opposite sides, then it is a parallelogram. And so we're given this, and we're wanting to prove this, okay? So I'm going to erase those off now. Okay, and so we know this is congruent to this, and this is congruent to this. So let's think about what we're going to do. What I want to say is I need to show that this is what I need to show. Okay? In order to say something's a parallelogram, I have to go to the definition, which would say that opposite sides are parallel, and another set of opposite sides are parallel. Okay? So that's what I need to do. The only problem is I can't do that unless I know some angles are the same. So I need to think about this angle being the same as that angle. Okay? Then I also need to think about this angle being the same as that angle. If I do angle DAC is congruent to angle ACB, I'll get these are parallel. Okay? And with the same kind of thinking, whoops, I need to put my red pen back there. If I use we'll do this situation right here. DCA is congruent to BAC. If I can show that, then I can say that this is parallel to this. And once I have both sets parallel, I can say it's got ABCD as a parallelogram by the definition of a parallelogram. So it's easier. So now we just got to think how we're going to get all those angles being the same. Well, we're going to have to somehow show that the triangles are congruent by one of our 6 rules, 6 shortcuts. So we have S, 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 congruency, S, A, S, A, S, A, S. And if they were right triangles, we could use hypotenuse legs, but they clearly aren't drawn right. There's no reason to believe that it's right, so we won't be using that. So we've got our 4 choices there. So we've got our 4 choices there, and it's probably going to be this one or this one because we have a set of sides. We have another set of sides, so there's your 2 S's. So that's 2 S's already. So we're probably not going to use these 2 because they only need 1 S. It's possible, but that's probably the way to go. And then the last thing is once you've shown the triangles, you can go C, P, C, T, C for the other parts. And then we can go through our parallel line rule. So we've got a plan. Let's formally do this, okay? So we're going to flip back and forth here. So one of the things I notice here is that this is the same as itself. So I think what I'm going to do is not use this, not use this, not use this, and not use that because I have a set of sides now. So I really know what I'm going to do. So let's go ahead and do it. I'm going to turn the page. We'll come back and forth between it. So the first thing is we are given some things. So we have AB. So these are what we're given. AB is congruent to CD. So I'm going to write that in the first bubble. AB is congruent to CD. And the reason it's true is given. We also know, I'm going to make these bubbles bigger, that BC is congruent to AD. So I got this here too. So I'm going to go back. BC is congruent to, what was it? AD. And if you just wanted to know what's going on here, this gives you a set of sides, this gives you a set of sides. Okay? So I'll go back. These two ideas are going to leave. We need one other piece of information. Well, I need to write down that this was given. Okay? I need another bubble of information, and it's the one I noticed right here. AC is congruent to itself. So we can say AC is congruent to AC. And why is that true? Because that's a reflexive. The reflexive property of segment congruence, if you like. So it's reflexive. And so that gives us another S. So we can make a bubble here. That says, now we've got to get this right. So we've got to get the corresponding parts. So we know that B and D are going to be the same. Okay? So let's start with, and then we're going to go B, so I'm going to go B to C to A. So let's write that down. Triangle B to C to A, this is a triangle by the way, is congruent to triangle. Now this we got to get tricky. So we started with B and we went, we started with B and we went to the right. So I'm going to start with D and go to the left and then up the diagonal here. So DAC. DAC by side, side, side. So there's our flow chart so far. And now that I know that, I'm on my way to get my angles. I know a couple things here. So let's go to picture. I know angle C is congruent to angle A. Angle C is congruent to angle A by CPCTC. And I also know that angle B is congruent to angle D. Excuse me. That angle, I just totally messed that up. Let me erase this. Okay. So, I still want green. So I know I got to name that angle. This is angle C here, but it's BCA is congruent to angle DAC. BCA, DAC. That doesn't look like a D. Whoops, didn't get the erase. And that would be by CPCTC. Remember, corresponding parts of congruent triangles are congruent. Okay, and we've got a similar argument for the other one here. I wonder if I can get this in the bubble and get it on one screen here. It's not like a big whiteboard. So let's go back. So the other thing I have here is I need to say that angle BAC is congruent. Angle B, whoops, that's not what I wanted. Angle BAC. Still getting my writing skills on the tablet working. Angle, that was BA, so B to A to C. Well, I want the same thing, but I'm going to start with D to C to A. You see, I'm taking my time trying to get everything labeled right, because it really makes a difference to communicate. Okay, and that's by C, P, C, T, C as well. And so now we can, now I'm running out of space here, but what I can do is go, this leads us to, well, I'm going to go to the other screen. I'm going to go to another screen here. Both of these lead to something else. So I'm going to scroll a screen over. And the first one, and then there's a second one. So I'm going to go back. So there's a first one there, and a second one there. And B to C to A. So I'm going to go B to C to A, B to C to A. So BC is parallel to AD. BC is parallel to AD by, those are alternate interior angles. Alternate interior angles. Okay, and then if I go back a screen, we got a similar thing for the other thing. So if I go back to, we've got AB and CD. So I'll go to, I did that again. AB is parallel to CD by alternate interior, because the alternate interior angles are congruent, I guess. It's a better way to write it for the other one as well. And now that tells us that quad ABCD is a parallelogram, because it's the definition of a parallelogram. There's our flowchart proof. It took us 3 screens to do it in about almost 15 minutes to explain it all. I hope that it made sense.